Good day everyone and welcome to watch my video presentation. My name is Chung Ji-jun and my metric number is 142610. In this video, I will present the explanation about the concepts of hierarchical design, modularity, regularity, and locality using a pair of Bluetooth headphones. When we look at this picture, it is understood that the structure of Bluetooth headphones consists of systems, modules, components, and functions. Also, there will be subsystems, submodules, subcomponents, and subfunctions. First of all, let's have a look at the sound system. The module used here is earpiece speaker module. For the components, we have two small audio drivers, voice coil, magnet, and con. Its function is to listen to audio. Next, we look at all other subparts. For voice system, we use microphone module, and a microphone is needed as the component. Its function is to detect sound or audio. Then, for control system, we use button module, and we will have remote control profiles for headset, hands-free, and audio or visual as the component. It will be pressed to adjust volume and play or pause action. After that, for wireless system, we use Bluetooth module, and a Bluetooth system on chip is needed as the component. This helps to connect to a device wirelessly. Here, we stick the Bluetooth system on chip together with the Bluetooth module to make the whole mechanism work as shown in the image below. Lastly, for charging system, we use battery module. In this part, a lithium-ion supercapacitor as a rechargeable battery and a micro USB charging port are used as the components. Its function is to charge the Bluetooth headphones. After all, we can summarize all of the information into 5 branches. We have the first branch as sound system, the second branch as voice system, the third branch as control system, the fourth branch as wireless system, and the fifth branch as charging system. With that, this information can be used to explain the concepts of hierarchical design, modularity, regularity, and locality using a pair of Bluetooth headphones. For hierarchical design, the use of hierarchy or a divide and conquer technique involves dividing a module into submodules and then repeating this operation on the submodules until the complexity of the smaller parts becomes manageable. As we can see, the sequence goes from systems to modules, then to components, and lastly to functions. It means that the analysis is getting much simpler and more manageable. The hierarchical design approach reduces the design complexity by dividing the larger system into several submodules. By following the direction of this arrow, it can be observed that the complexity of this overall design is decreasing. For modularity in design means that the various functional blocks which make up the larger system must have well-defined functions and interfaces. Modularity allows that each block or module can be designed relatively independently from each other. As we can see here, the voice system has no influence to the wireless system and vice versa. To be more particular, all systems here have no effect among each other, so they work independently since there is no ambiguity about the function and the signal interface of these blocks. The concept of modularity enables the parallelization of the design process. When we refer to the orange dotted line, we can see the parallel design process. They are having no influence among each other and they work on their own part only. For regularity means that the hierarchical decomposition of a large system should result in not only simple but also similar blocks as much as possible. So let's understand this with several examples. For sound system, we have voice coil, magnet, and con that are easily found in the market and commonly used in many headphones. Next, for voice system, we have microphone that is generally used too. Then, for charging system, we have lithium-ion supercapacitor, which is a common rechargeable battery, and a micro USB charging port that many other devices are also using it to charge. In summary, these components can be easily found, and hence, it is easy to get their replacement if broken, because we can obtain a supply that comes with high availability. Besides that, When a supply is a lot, the usage seems regular. Thus, for regularity, it is understood that the simplification of the design process must consider regularly used components or simple utilities that can serve the right purpose to the system. With regularity, the system is built to bring convenience to people instead of trouble. For locality, the concept of locality ensures that connections are mostly between neighboring modules, avoiding long-distance connections as much as possible. This last point is extremely important for avoiding excessive interconnect delays. Let's discuss this with several examples. For sound system, the speaker is built to play sound for ears to listen, so the earpiece speaker module must be close to ears. For voice system, the microphone is used to record what we say, and so it must be close to our mouth to detect our voice. For control system, we use hands to press the button, and so this functionality must be applied on button module. For wireless system, by recalling the previous mechanism, the Bluetooth system on chip that stick together with Bluetooth module can avoid long-distance connections. By sticking together, it reinforces the wireless system. For charging system, the rechargeable battery must be close to the micro USB charging port so that the excessive interconnect delays can be avoided, and hence the battery can charge faster and more efficiently. Therefore, with locality, it eliminates as much dragging factors as possible to enhance the effectiveness and the efficiency of the system so that the system can work perfectly. That's all for my video presentation. Thank you so much for watching. Goodbye.